Okay, in this video, we're going to do an introduction to Extrema on intervals and kind of what that means, what that looks like, how to find them. We'll do one or two examples, but mostly definitions looking at extremas. So first of all, what are extremas? Those are, another word for those are maxes and mins, right? So when you looked at quadratics, quadratics look something like this. Okay, that's a basic quadratic graph. This point right here, that's an extrema. Okay, and so in this case, if that were an extrema, that would be a maximum because it is the highest point on that graph. So that's what we're looking at. And these points where the extrema occur, these are called the critical points. So in this video, we're going to look at what the critical points mean, how do we find critical points, and how do we use critical points to find extrema. Okay, so first of all, so looking at definition of extrema, a more formal definition, looking at a function that's defined on an interval. So an interval I right there. So that I represents any given interval. Sometimes it's like this, right? Where A and B, these are x sub 1 to x sub 2, depending on what book you're using. So the f of c is the minimum. It is the minimum on that interval if f of c is less than or equal to f of x for all x, meaning if that value, that c represents the critical point, if that critical point is the lowest value, it's lower than any other x value on that graph, it's the minimum. The second one says the opposite. It's a maximum if f of c is the largest, the highest value. So again, remember f of c, that's the y value at c, okay? So if that y value is the largest, then we say it's the maximum. And then these are also called, the plural part is the extrema, or the extreme values. Okay, those are meaning the same thing, the extrema or extreme values. And then the absolute minimum, absolute maximum are, because some graphs continue on and could have a couple minimum, like right here's a minimum value, but this would be the absolute minimum value because it is lower, right? So that would be the absolute, and this would be a local. Beautiful writing. That would be a local min because in the area around that point, it is the lowest point. But if you look at the global portion of the graph, which is all of it, then this point right here is the global or absolute minimum. And then the extreme value theorem, all this says that, hey, listen, if f is continuous on a closed interval, and this is your interval, then it has to have both a minimum and a maximum. So any graph, if it's continuous, because you could have broken graphs, like if you have piecewise functions, it has to be continuous, then it's going to have both a maximum and a minimum. And that's what we're going to look at in finding the max and mins. All right, so you should have these tables filled out using those definitions right there. If you needed to pause it, go back and pause it so you can write this stuff down in your notes. It's very important. And then relative extrema, those are, I called them local max or mins, but this book calls them relative max or mins. It's basically if something is a relative maximum, then in that area, that's the highest point, right? So if you have a graph right here, that's a relative max. So graphs can have more than one relative max and mins, but can only have one absolute max or min, right? So same thing with the relative minimum. Down here, they call them local. So they mean the same thing. Local maximum, relative. So relative to that area, local to that area, they are the highest or lowest points that you see. And remember, pause the video if you need to catch up. Okay, I want to make these videos as short as possible so you can pause them and write down what you need to write down. But in this case, in parts A, B, and C, we are finding the relative extrema of those functions. And we're going to use the graph to help us out because the graph gives us some sort of range to look at, or domain to look at, or interval to look at. All right, so first of all, when we're finding relative extrema, first thing you should do is find the derivative. Okay, so go ahead and pause the video and find the derivative of this function right here. So hopefully you found the derivative. Kind of follow through my work. If you need to pause it at any time, please pause it and try this on your own. Very important. So we do the quotient rule, low d high minus high d low over low low, right? So you have the low times the derivative of the high minus the high times the derivative of the low, and that's all this over low low. Then from there, it's just simplifying. Simplifying as far as you can go. I noticed out of everything, I could take out an x squared, so that's what I did here. I took out an x squared. And then from there, once I take out an x squared, then I also noticed I could take a 9 out of the top. So I took a 9 out of the top, and then you can simplify those, 2x squared minus 3x squared, and you get to here, right? So that's as simple as it can get. But to find critical points, they occur where the first derivative equals 0. Those will help us find our critical points. So they occur both there and they occur at endpoints, but we're not given endpoints here. So we set the first derivative equal to 0, and you see that our critical points are at positive and negative 3 in this particular. Now here they want us to look at the graph, and here's the graph of that function that we just found the derivative of. You notice we're only looking at this interval that they give us. So x equals negative 3. We're not even going to look at or consider that point because it's not on this graph that they show. All we are going to look at is x equals 3. So when x is equal to 3, we need to figure out what y is. So we're going to plug in 3 into the function right there. And when you plug that in, you end up getting y is equal to 2. So you plug 3 in for x there and in for x there, and you end up getting 2. Right, so then 3, 2, that is our relative maximum. Let's try another one here. Looking at the graph, so if you have it in front of you, go ahead and graph the absolute value of x, but we should all know what the absolute value of x looks like. So right here is what the absolute value of x looks like. Now in this case, if you were to go through and try to find the derivative at this point right here, there would be no derivative. The derivative does not exist, right? Where the derivative does not exist, that is a critical point, right? A critical point is described as, hey, something is happening. Either the first derivative is 0 or that derivative does not exist. And this derivative does not exist because this right here is a corner. The corner, the slopes from the left and the slopes from the right are not approaching the same value. So these slopes are just -1, right? So these slopes are -1. They're constant -1. These slopes are +1. So as you're approaching, in order for the derivative to exist, the slopes need to be approaching the same value. See, if it's a smooth curve, these slopes are approaching 0, just like these slopes are approaching 0. But in this case, these slopes are not approaching the same point. So that's a critical point, and the derivative does not exist. So even if we tried to find the derivative, we would not be able to because it doesn't exist. That means it's a critical point. And in this case, that is a relative minimum, or we know it's also a absolute minimum because it doesn't get any lower than that, right? So with absolute value, with corners, also we'll talk about it a little bit. Cusps is another one. If you have a graph that comes in like that, that is a cusp. These slopes don't come together to be the same value. These are increasing, and these are increasing in a different way. They're not coming to the same value. All right, let's look at one more here. Go ahead and try this one. So find the derivative and then set that equal to 0 to see if you can figure out the extreme values. Try this on your own. You find the derivative, set the derivative equal to 0, then to determine which one's max or min. If they're both max or min, you would go ahead and find the y values. So the derivative is cosine, and when cosine is equal to 0, I know that that occurs at pi over 2, 3 pi over, and it keeps occurring, but let's just look at from 0 to 2 pi. Because of that graph that they give us. Where's it at? Here. Okay, we're just looking in that area. So we're looking at pi over 2 and 3 pi over 2 for this particular one. And so sine of pi over 2 is 1, and sine of 3 pi over 2 is -1, meaning our critical points occur when x is pi over 2, y is 1, and x is 3 pi over 2, your value is -1. Right, so then that means, in this case, this is our max at pi over 2, 1, and then our minimum is at 3 pi over 2, -1. Always remember, when it's asking for where the critical point or the max and min exists, right? They're asking about the x value. The x value tells you where. If they're asking what is the max or the min or the value, that is a question as to what is the y value, right? So the where it exists, that's your x, and then what's the value? So right here, pi over 2, and 3 pi over 2, that would be the where. What is the value determines which one's the max and the min. That's the 1 and -1. Those are your y values. And then to define a critical number, it's where the only place the extrema can occur. Now, I have 3 options. Number 1, that's where the first derivative is 0. Always go there, okay? Number 2, extrema can also occur where the first derivative does not exist, and we've talked about that. Those are corners, cusps, and vertical tangents. And then number 3, you want to look for extrema at the endpoints. Those are the only 3 areas that your extrema can occur, and they are all considered critical points. So you have to look at them and determine whether or not they're important. And so then this next definition just kind of restates what I just said. They only occur, the extrema only occur at critical numbers. So you really need to know how to find critical numbers with graphs, right? Which are those 3 methods listed just above. And then the last thing I want you to get from this video is to fill this out, the guidelines for finding extrema, and then in the next video we'll actually do an example. But since we're here, go ahead and pause the video and then write these down, and we'll do these in the next example. But we already found critical numbers. That's where the first derivative is equal to 0, the first derivative doesn't exist, or the endpoints. Then evaluate, actually find the y values of the original function, not the derivative, the original function at those points, and then evaluate your endpoints as well. And then you determine which is the max and the min. We'll do an example when we come back.